Greetings, I am Mahesh Kumar Basantani, a professor in biotechnology at Sri Ram Sarup Memorial University. I'll be teaching a course on next generation sequencing technologies. Next generation sequencing technologies have significantly enriched our understanding of the genome architecture, complexity, and evolution. Diverse NGS technologies and platforms are generating huge amounts of nucleic acid sequencing data on a regular basis. The deluge of sequence data and information pouring from whole genome sequencing projects is tremendous, and these technologies have wide-ranging applications in plants, animals, and microbes. Numerous computational biology approaches and bioinformatics tools and applications have been developed to systematically store, analyze, and annotate the sequencing data. The course aims to teach about varied NGS technologies and platforms, genome assemblers, and bioinformatics tools, and how they are used to sequence and assemble genomes and extract meaningful information from the sequenced genomes. The specific objectives of the course are to appreciate the historical perspective of nucleic acid sequencing, to understand the principles and concepts behind NGS technologies, to understand the basics of sequence data analysis, to learn about varied genome assemblers, to understand about the problems and pitfalls associated with genome assembly and analysis, to learn about some possible solutions to overcome the problems associated with genome analysis, to learn about the role of cloud computing for NGS informatics, to understand the scope and importance of genome sequencing. The curriculum for the proposed course on next generation sequencing technologies will be divided into 3 units. Unit 1, entitled Techniques and Platforms for NGS. It will cover topics: history of nucleic acid sequencing, Sanger sequencing method, introduction to next generation sequencing and cyclic array strategies, Illumina, ABI solid sequencing, nanopore sequencing, PacBio SMRT sequencing, and some future trends in next generation sequencing. Unit 2, entitled Computational Biology meets NGS. It will cover topics like fundamentals of next generation sequencing, data analysis, and genome assembly. Genome assemblers like Cap3, Nubler, Abyss, Kebab, Velvet, and more recently the Kanu. Assemblathon, cloud computing for NGS data analysis and genome databases. Unit 3, entitled Problems, Solutions and Applications of NGS. It will cover topics like repetitive sequences and genome size, problems associated with large size, higher ploidy and heterozygosity of plant genomes, development of improved assemblers like Mazurka, JR assembler and Grids assembler, scope and applications of next generation sequencing. The proposed course will be a 10-week 2-credit course which will be scheduled as follows. The week 1 will cover history of nucleic acid sequencing and Sanger sequencing method. The week 2 will cover introduction to next generation sequencing and cyclic array strategies. In the week 3, Illumina, ABI solid, nanopore and PacBio NGS techniques will be covered. Week 4 will cover modules on future trends in NGS and basic principles of NGS data analysis and genome assembly. In the week 5, genome assemblers and their relevance will be taught. The week 6 will cover assemblathon, cloud computing and genome databases. In the week 7, problems associated with genome assembly and possible solutions will be taught. Week 8 will cover the importance of improved assemblers like Mazurka and Grids. In the week 9, scope and applications of NGS in life science research will be taught. Finally, in the week 10, the course will complete with a summary of the contents taught throughout the duration of the course. The assessment will include 30% assignments and 70% for final examination. Any student who has studied basic courses in molecular biology and bioinformatics at the undergraduate or postgraduate level can opt for this course. And finally, the learning outcomes. After the completion of this course, the students will understand the principles behind diverse NGS techniques and platforms. They will be able to differentiate between different NGS technologies. They will understand the use of genome assemblers for analyzing sequence data generated from NGS platforms. They will understand the importance of modern approaches developed for genome assembly. They will learn about the applications of NGS technologies. They will understand how nucleic acid sequencing has become integrated to the landscape of genome research. And finally, they will be able to take informed decision regarding the choice of a fitting sequence strategy for their research projects. Thank you.